Hello everyone. So let's start by the first problem for the revision problems for the final exam. So this problem is about the moment of inertia, and the question is to find Ix, which is the moment of inertia about the x-axis. To do that, we need to divide our section into well-known geometrical shapes. So this is the first section, section 1. This is second section, and this is my third section. And please note that the third section, as you can see, is a void. So how to do this exercise? Let's start by finding the moment of inertia of section number 1, which is a triangle. So here, the center of gravity of this triangle is somewhere here. It's not located on the axis where I want to find the moment. For that reason, I have to use the parallel axis theorem. So I can say here that I1 is equal to 1 over 36 BH cube plus AD squared. And because I want to find Ix, so the base B will be the dimension parallel to X, so it will be equal to 300. And H will be equal to 200 millimeter. If the question was to find Iy, then the dimension parallel to y will be the base. In this case, it will be 200. And the other dimension will be the height, which is 300. Okay, so pay attention. We need moment of inertia about which axis? The axis, the dimension that is parallel to the axis where I want to find my moment of inertia, then it will be the base. The other one will be the height. So let's solve this. 1 over 36 multiplied by 300 multiplied by 200 power 3. The area of this triangle is 1 over 2 times 300 times 200 times d squared. D is the distance between the center of gravity and the axis where I want to find my moment of inertia. So in this case, it will be equal to 1 over 3 multiplied by 200, and all are squared. This is power 2. So this dimension here is 200. And I want to take 1/3 this dimension because my center of gravity is located at 1/3 from the base of the triangle. So if we do the calculation here, we will get 200 millimeter. Don't forget the unit in the exam. So I2 is the moment of inertia of the rectangle. So also the center of gravity of the rectangle is somewhere here in the middle of my rectangle, and it's not located on the axis where I want to find my moment of inertia, so I have to use the parallel axis theorem. So here I have I2 is equal to 1 over 12 BH cube plus AD squared. In this case, my base is equal to the dimension parallel to X, which is 300. And H will be equal to the other dimension, which is 200. Okay, so 1 over 12 multiplied by B multiplied by 200 cube plus the area, which is 300 times 200 times d squared, and d, as I said, is the distance from the center of gravity till the axis where I want to find the moment of inertia. In this case, it's equal to 100. And if we do the calculation here, we will get 800. Okay, we still have I3. I3 is the third section, is a circle. So also the center of gravity of the circle is not on the axis where I want to find the moment. So also I need to use the parallel axis theorem. So the moment of inertia of a circle is equal to pi over 4 multiplied by radius power 4 plus AD squared. So here I have pi over 4. The radius here is 75. The area of the circle is pi times area squared multiplied by d squared. D is the distance from the center of gravity for the circle, it's in the middle of the circle, till the axis where I want to find my moment of inertia, so it's equal also to 100 squared. If we do the calculation, we will get here 201,565,075.5 millimeter 4. Don't forget that third section is a void. So here, if I want to find the total moment of inertia, I have to say that I total is equal to I1 plus I2 minus I3. Okay, don't forget the minus because I have a void, a hollow section for section number 3. If we do the calculation here, we will get 794,434,924.5 millimeter 4. Just so this is the end of this problem. Just a quick remark for you for the final exam. Please review the location of the center of gravity of different sections. In addition to that, don't forget to memorize the moment of inertia of the well-known geometrical shape. The sheet is already uploaded on Blackboard, so you can see it from there. And just one remark, if you got some triangle like this that is not a right triangle, you can deal with it. You can divide this triangle into two sections, two separate sections, two separate rectangle triangle. Or you can just say, this is my triangle. So my center of gravity is located at 1/3 h, and I is equal to 1/36 bh cubed. So it's exactly the same. Either you use it as a full triangle, so the center of gravity will be same, located at 1/3 from h, and the moment of inertia will be 1/36 bh cubed. Or you can divide your triangle into two right triangle. In this case, you will have center of gravity for each triangle located at 1/3 also h, which is the height of the triangle.